Hey guys, it's Miss Sims here, and it's time to look at some of our notes for today. So I'm going to start off with here. I put these into the Blackboard. So these are some of the class notes, and I just kind of wanted to talk to you about them pretty quickly. So first thing I want to point out is we have some rules. I just really cut out the 4 that you're really going to use today. So first one is order of integration. Normally we need to go from A to B, but if they are backwards, then we need to put a negative in front of the integral. So most of the time what happens is it's in the wrong order. We switch it and put the negative out in front. All right, the 0 rule says that if I go from A to A, meaning I don't have any space, obviously I can't have any area under the curve. We have the constant rule, which basically says if there's a constant here, I can shift it to the outside of the integral, and that really kind of works for the negative sign. If there's a negative inside, I can shift it to the outside of the integral. And the last integral rule here is that if I have an integral in which I'm adding up 2 functions, then I can separate it into 2 different integrals. The one I left off that it's on your sheet tells you that if you have an integral that goes from A to B plus, and I'm kind of being a little bit lazy, and then I do an integral from B to C of the same function, we'll call it f, then I really can do the integral from A to C of f. And again, I was a little lazy. I should have said f of x dx, but I don't want to write all that. So basically, again, we're going to kind of write it the other way. If I have a whole integral, I can break it into 2 parts that I know. Okay, so if I have a whole integral, I can split it in the middle and the overlapping parts right there. And so that's going to come in handy too. So I'm going to move on here to my next page, which is an example. So you can see in this example, this is number 2 out of your textbook. They have told me a couple things. If I'm going to do f of x from 1 to 9, the answer is -1. If I go from 7 to 9, it's 5 for f of x. And if I go from 7 to 9 of h of x, it's 4. All right, so I'm going to go through these pretty quickly here. And let me just erase that out of there. Maybe I can. All right, so looking at question number A here, they want me to do from 1 to 9 of -2 f of x. So on question A, basically what I know is in the rule, the -2 can come out to the front, and I can rewrite it as 1 to 9 of f of x dx. And so we just said that that was equal to -1, so I'll have -2 times -1, and so that would be +2. All right, then I'll go on to question number B here. And so this one has 7 to 9 of f of x plus h of x. So based on our rule, I know that I can split that. So I can go from 7 to 9 of f of x plus 7 to 9 of h of x. And again, I was a little lazy. I should put dx with each one of those, but a little lazy. So then I just pick these off of right here. So there is 7 to 9. That would be 5. 7 to 9. That would be 4. So my overall integral would be 9. Okay. Now for question C, I've got kind of the same situation going on here. The difference is I definitely have some constants. So I'm going to move the constant out, and then I'll go from 7 to 9 of f of x. And this time it has a subtraction sign. I'll move the constant out, 3, and then I'll go from 7 to 9 of h of x. So now I have 2 times, and then f of x was 5, minus 3, and h of x was 4. So I have 10 minus 12, which would be -2. All right, now for question D, they want me to go from 9 to 1, so that's backwards. So I know that would be the same as negative from 1 to 9 of f of x. So that'd be negative, and then 1 to 9 was -1, so negative is +1. All right, then I'll do question E. So in question E, it wants me to go from 1 to 7. So this is what I know if I'm trying to get 1 to 7. Again, about f of x. I know that if I want to do 1 to 7 of f of x, that I can add 7 to 9 for f of x. And again, that's that little overlap rule. That have to equal the integral from 1 to 9 of f of x dx. Now, some teachers are all like, let's do this in our head. I really want to write that integral down, and then I just come back and fill my numbers in. So from 1 to 7 is what I'm looking for, so I'm going to leave that. So I want to figure out this integral, 1 to 7 f of x dx. Again, I was a little bit lazy with writing the dx, but I know these answers. So 7 to 9 was 5. And then 1 to 9 was -1. So if I just subtract 5 to the other side on both of those, I'll end up with the integral from 1 to 7 of f of x had to be -6. Okay, so that's that one where, again, I was looking 1 to 7, so I know 1 to 7 overlaps 7 to 9. So then that would be the whole integral from 1 to 9. And then I just put my numbers in. So 7 to 9 was 5. 1 to 9 was -1. And then I just simplified. All right, so the last one here is f. And again, I can split that up. So I want to do from, well, it's backwards. So actually, let's leave it as backwards. So 9 to 7 of h of x, and then minus 9 to 7 of f of x. And now apply the switching rule. So that'd be -7 to 9 h of x minus, that'd be -7 to 9 of f of x. So again, I'm kind of showing everything here. So that'd be negative, and then 7 to 9 is 4. Minus and minus turns to plus, and then 7 to 9 is 5 on f of x. So I end up with -4 plus 5, which is 1. All right. I'm going to go ahead and move on to my next example. I'm trying to get you just one video. It might be a little bit longer, but hopefully it's not too bad. So the mean value theorem for integrals basically tells me that when I want to do the mean value, which is it's kind of like doing the average, that I want to do the average of the endpoints times the integral. Okay, so I've got two problems for you to do. This first one, they tell me essentially to do it with areas. So I'd want to do the integral from -4 to 2. So that would be 1 over -4 minus 2. And I think it's b minus a. So hold on. I knew I was writing that backwards. Let me fix that. So b minus a. So b is the top. So that would be 2 minus a -4. And then we'll call this f of x dx. So that would be plus, so that'd be 1/6. And then I'm to do this with areas. So I'm to do the area, which that's a triangle. So that'd be 1/6. And that'd be 1/2 base times height. So that would be 1/6. The base goes from -4 to 2. So 4 and 2 gives me 6. So 1/2, 6. And then the height there, it looks like that's 3. So I end up with the 1/6, and the 6 will cancel. I'd have 1/2 times 3. So that'd be 3/2. All right. Now, in this example, I've got to do my own integral. So I want to do the integral from e to 2e of 1 over x dx. And again, I'm doing the average value. So on the top out here, I do 2e minus e. And so that will give me average value. I need that average part on the outside. So that's pretty easy. That's 1 over e. All right. And then my antiderivative here, hopefully we know my antiderivative of that would have to have been the ln of x. And I need to evaluate that for my two endpoints, which would be 2e and e. So when I evaluate, I do the top, so the ln of 2e minus the bottom, the ln of e. and then I have a 1 over e on the outside. All right, so as I simplify this, I might want to think about this as really the ln of 2 minus or plus the ln of e, because that would be a product, and then I have minus the ln of e there, and then I have 1 over e. So those end up canceling, and I have 1 over e times the ln of 2 on this problem. That wasn't too bad. All right, so my last example is just me doing some antiderivatives. And again, they're ones that we can kind of figure out, but we have to plug in the two endpoints. So I know that if I want to think about taking what did I take the derivative of to get cosine? That would have been sine of x. But then I have to evaluate now for my two endpoints, which is 0 to pi over 2. So when we evaluate endpoints, we always put the top number in first. So that would be the sine of pi over 2 minus the sine of 0. So hopefully we all know sine of pi over 2 is 1 minus the sine of 0 is 0. So I get 1. All right. So here on the second one, so again, I had to think about what did I take the derivative of to get 3x squared. So if I think about that, that would have had to have been x cubed. So think about x cubed would be 3x squared if I took the derivative. So now I want to evaluate that from -1 to 2. So I'm going to put in 2 cubed minus -1 cubed. So that would be 8 minus -1. And so I'll end up with 9, right? So I have to think about what the antiderivative had to be, and then I will evaluate using the two endpoints, always putting the top endpoint in first, the bottom endpoint in second, and taking the difference in. So I hope these will help you through your notes. And again, please work together as a class. Have a good day.